you. As Max already mentioned, my presentation will be about LVGL version 9 and the RT thread RA6, and actually I will tell about RA8 as well. Both of these are HMI related boards, and that's why these are quite related to LVGL as well. So let's start with what LVGL is. LVGL stands for Light and Versatile Graphics Library. I can proudly say that right now LVGL is the most popular free and open source embedded graphics library. You can use it to create beautiful UIs for any microcontroller, microprocessor, and for any display type basically. It's a full-featured solution. It has more than 30 built-in widgets, including keyboards, sliders, charts, buttons, tab views. Basically, what you can see in an Android or an iOS application can be realized with LVGL as well. We have a powerful style and layout system as well. These are inspired by CSS. CSS is the styling scheme of the web pages, so the same technology or same concept which makes the web pages so responsive and powerful available in LVGL as well. Regarding the layouts, we have Flexbox and grid layouts, which helps you to automatically arrange the widgets nicely next to each other, below each other, wrap into new lines, or create a table-like grid layout with many options. And regarding the styles, you can choose from more than 100 style properties to customize your widgets and the parts of your widgets in a very deep way. LVGL comes with a quite advanced typography system as well. It supports many languages like the Asian languages, Chinese, Korean, or Japanese, the Arabic languages like Persian, for example, where you can mix right to left and left to right writing directions. And of course, you can use the more common Latin-like or more simpler Latin-like languages as well. LVGL is a free and open source solution. Its source code is fully available on GitHub and is distributed under MIT license. In the practice, it means if you want to use LVGL for commercial purposes due to the MIT license, you can do it very easily. All you need to do is adding a sentence in your documentation, user guide, or README saying that we have used LVGL in this project, and that's all. You don't have to pay anything. There are no royalty fees. There are no hidden licensing or subscription fees. It's really free. You can download it and it's yours. As I already mentioned, LVGL is quite popular. According to the statistics available on GitHub, I see that it's downloaded in every minute from GitHub. Actually, it's closer to 40 seconds right now. Besides that, it's already supported by the leading players of this industry, including the main chip vendors and the main software projects like RT thread. LVGL is a platform-independent, platform-agnostic solution that you can use on technically any modern microcontroller, microprocessor, used with any RTOS to drive any kind of display, including monochrome, OLED, e-paper, TFT, or even monitors. LVGL is supported by several third-party UI editor tools. Just to mention a few, maybe you have already heard about Squareline Studio. We were working closely previously. And there is another UI editor solution called Easy Studio. It's a free and open source solution that which is also available for you, and I recommend trying it out. And finally, I'd like to tell you that we are doing several services from UI design to UI implementation, including some consulting services. So if you would like to get some professional support or professional design and development directly from the LVGL team, feel free to contact us and we can discuss how we can collaborate. If you are new to LVGL, probably you would like to see what kind of UIs you can create with it. Here you can see some images, but on our website, if you click this link, you can see our demo page. Here, these demos can be clicked, so you can see how LVGL looks in the action. You can scroll here. You can see your default keyboard. These are the default settings. These are the default styles. So if you create a switch or a slider, for example, it will look like this. We have some charts as well. Oops. Some meters. And some other stuff here. These are created or arranged by the Flexbox layout, for example, that I have mentioned. I just created a lot of items here and told LVGL that LVGL put these below each other and set maximum width for each. So it's quite easy to arrange items like this. Here we have a smartwatch that we have designed for NXP. Actually, it was created in SquareLine Studio, and we didn't have to write even a single line of code. All these were created by a designer in SquareLine. The interesting thing is in this demo is that we haven't used any images here. All these shapes and gradients are rendered by LVGL software render engine, and these are not images, meaning that you can customize them in runtime and change the properties as you like. And we have a music player demo here as well. And we have a printer demo here too. Feel free to try this out if you are curious. It's lvgl.io/demos. Okay, of course, if you would like to try out LVGL, you can do it very easily with RT-Thread as well. LVGL is available in RT-Thread's software package manager, and I can say that it's already downloaded more than 26,000 times, which is quite amazing. So if you would like to use LVGL, you can use the regular methods as you would at any other components. You can just enable it in menu config or use the component manager in RT-Thread Studio. It's really only a few clicks or key presses to add LVGL to your project. Besides that, LVGL is already supported in the RT-Thread BSP packages. I think I can say it in a confident way that all the boards which are related to HMI and has a display are supported for LVGL as well. And the third thing, which is something really great, RT-Thread has a special interest group for LVGL. So if you have any LVGL and RT-Thread related questions, you can ask this special interest group or SIG, which where you can find professional and the curated list of LVGL and RT-Thread experts. As far as I know, this interest group is mainly targeting the Chinese audience. So if you have any questions, especially from China, feel free to reach out to this group and you will get the best-in-class support for sure. I'd like to tell you a few words about what kind of new things we have in LVGL version 9. I think one of the biggest improvements in general is that we have a way better rendering architecture. First, now all the operating system related things are used during rendering as well. In the practice, it means that if there is a GPU in your microcontroller and that GPU is working in the background, the rendering engine or the rendering backend of LVGL can yield a rendering task, which means that your operating system like RT-Thread can run another task while the GPU is working. Normally, it lowers the CPU usage by 30 to 50%, so it's a huge improvement to free up the CPU for other tasks. Another great improvement is that in LVGL version 9, you can use multiple CPU cores or MCU cores for rendering. So, for example, let's say you have a microcontroller with 2 cores, you can use both cores for rendering. And if, let's say, there are 2 buttons next to each other, one of the buttons can be rendered by the first core and the other by the second core in parallel. Obviously, it can't double the performance because not all the rendering tasks can run in parallel. But in general, it means a 30% upgrade in rendering time. And the last thing for the rendering architecture, now we have built-in assembly instructions for the critical software rendering functions or algorithms. It typically means the blending when, let's say, we want to blend the color, maybe with opacity to the currently rendered image, or copy an image, maybe with opacity again. And if you need to do these kind of things, and if some assembly support is enabled, LVGL can use those to do this in a much optimal way. Besides the better rendering architecture, we have built-in drivers in LVGL in version 9. In version 8, all the drivers and the BSP and the hardware support was a little bit scattered around all the LVGL repositories, but now all these are centered around the main repository. So if you would like to use a display controller such as the ILI 9341, which is a quite popular one, you can do it very easily because we have a built-in driver that you can use with a single line of code. All you need to do is tell the resolution of your display and provide two callbacks. One callback to send commands to your display, and the other is to send the actual pixel data or the rendered image, basically. In these callbacks, you can use your SPI driver, parallel port, or anything else that you like. We also have high-level drivers like the Linux frame buffer device, DRM, Windows driver, or someone is already working a native driver for Macintosh as well, macOS as well. So if you would like to get started with LVGL on your desktop, you can also do it very easily because you can use these drivers. And in general, it's recommended to do the UI development on your desktop because you just have way more options and way more debug options. You can enable all kinds of extra compiler options to help you to detect double free or use after free and these kind of things. And once you have figured out all these and created a UI on your desktop where you have seen the UI in a window on your monitor, you can use the actual UI code on the embedded system as it is. You just need to copy paste the UI code. Obviously, you need to use a different driver, but the UI code where you have created the widgets and added the styles and added the logic is the very same. So it's quite effective to do the development this way. And finally, we have added some great new features in version 9 as well. First, you can use a better and more versatile gradient engine in LVGL. You can use, for example, create a gradient like this. You don't need any third-party libraries for this. It's built into LVGL, and you can just set up the parameters, and it will render it for you in runtime. If the rendering takes a little bit long, of course, you can render it into a canvas widget and use this canvas as an image. So you can pre-render it if you like. There are some more examples here. For example, this metallic knob was created with a conic gradient where it goes from this gray color to white and it's repeated 3 times. And there is no image required here, so you can do all sort of magic as these are just parameters in your code and can be changed at any time for animations or styling or anything like that. This is the example. It's an example for a radial gradient, which is used as a background. And here we have some buttons. These are the already existing or the previously existing horizontal and vertical gradients. But here you can see a linear gradient with which has some angle. And here we have a radial gradient. If you would like to try these out, you just need to call, for example, LV example style 18, and you can check out the source code as well, and it will create these buttons for you. Another interesting feature which was added is the Lottie animations. If you haven't heard about it yet, Lottie is quite similar to GIF, just way better in all aspects, basically. First, it's vector-based, so you can scale it anyhow you want. It can be this small or screen-sized. It also has the whole color range because it uses ARGB 8888 colors instead of the 256 color palette of GIF images. And finally, the file size itself for the same animation is smaller for Lottie than it is for GIF. And you can do animations like this with Lottie. For Lottie rendering, we are using SORVG, which is a vector graphics library supporting a lot of things. And it happened that it supports Lottie animations as well, so we are using that library. And to make the compiling all this complicated stuff simpler, SORVG is integrated into LVGL. So if you download LVGL or use RT-Threads software package manager, you will get SORVG as well, and you just need to enable it in LVGL's configuration file. Okay, let's continue with the RT-Thread development boards. So the first board that I like to tell you a few words about is the RA6 board. It has a 480 by 2072 display and a Renesas RA6 microcontroller running at 120 megahertz. It also has a good amount of RAM and flash. All these together result in a quite capable display, and this microcontroller is way enough to create smooth animations on this display, and this RAM and this flash is enough for even very complex UIs. It also has a GPU. Renesas GPU is called Dave2D. It's a quite good one, to be honest, which can do a lot of things for you. It can not only fill the background with a color or copy an image, but it can draw rounded rectangles, it can draw triangles, it can draw gradients, rotate images, so many things. Interestingly, in the practice, we found that usually Dave2D, the GPU, is not really faster than software rendering. Obviously, it's faster in the complicated tasks like image rotation, but in general, it has quite the same performance as the software rendering with pure CPU has. The big thing is the GPU is working in the background. So with the new updates in LVGL version 9 that I have just mentioned, you can offload the CPU by letting RT-Thread running other tasks while the GPU is working. Normally, it lowers the CPU usage by 30% or something like that, obviously depending on the actual UI that you are using. As you probably assume that it's quite easy to get started with this development board in the RT-Thread ecosystem, you can use the ENV tool to create an MDK carry project, for example, but you can create an RT-Thread Studio project as well. So yeah, it's quite the basic and typical workflow. Another interesting thing is the RA8 Vision board. It's another microcontroller from Renesas, but actually it's the latest one. If you take a look at the resolution, it has like a 3 times larger display, 4 times more CPU power, a little bit more RAM and same amount of flash, and the same Dave2D GPU. It wouldn't be a big deal so far, but the actual interesting part is this Cortex M85 core, which has the so-called helium support. It is the big thing at ARM right now and making a lot of buzz because these microcontrollers has a special feature called SIMD, single instruction, multiple data. In the practice, it means that you just need to have a single assembly instruction, and it can execute the same operation on multiple data. In UI rendering and the UI related context, it's very important because let's say when you would like to blend a semi-transparent red overlay over the whole UI, you need to multiply the red color with the actual opacity. You need to multiply the background pixel color as well add the two together, scale it a little bit. So it's a little bit of basic arithmetic operations, but you need to do it on like hundreds of thousands of pixels, so crazy amount of times. And if you can execute it on 16 or 8 pixels at the same time, it means just 8 or 16 times faster algorithm, and it's really crazy. ARM has a library called ARM2D, which is publicly available on GitHub and can be used by anyone. And the goal of this library is to support this whole Helium instruction set for this Cortex-M85 microcontrollers. And it provides an API for basic drawing operations like filling a rectangle or rotating an image or blending some images and things like these. And actually, this ARM2D library, which leverages the whole power of this Cortex-M85 microcontrollers, is integrated into LVGL. So if you would like to use ARM2D, you just need to drop in the ARM2D library into your project, enable it in LVGL's configuration files, and from that point, you can have the way faster software rendering. Actually, this software rendering with Helium is so fast that it can use less CPU than the GPU has. So yeah, it's something really awesome, and it's making a lot of buzz right now. Finally, I would like to tell you something very important about our future plans. This is happening right now, and we have just started to working on it. It's a UI editor toolkit. As I mentioned at the first slide, that we were working together with Squareline Studio for many years, but now we started to work on our own UI editor toolkit. We made a lot of interviews and asked a lot of companies about what kind of tool would make the most sense for them, how could we solve as much pain points for them as possible. And we have concluded that we need to develop a tool for developers, not the designers, because we found that the designers are always using Figma or some other designer tool and not really interested in doing some drag and dropping stuff in a random developer related software. So we will let the designers do the designs in Figma, and we will develop a tool for developers, which will make it as smooth as possible to bring the designs from Figma to an LVGL code. It will be the most important thing for us to build a quite stable and easy to use Figma bridge to our editor. As we are targeting developers, the common workflows of version tracking and similar things on GitHub, GitLab, or Bitbucket needs to work very, very well. Actually, it's also a very important aspect that the generated code should be as easy to use as possible. We don't want to just generate a bulky, dummy, large, do not edit code. Instead, we would like to make it work together with the developer, just helping you a bit where it's required. We will make this UI editor toolkit work as a VS Code extension, but it will be also available as a standalone desktop application. It will also has a plugin system which will allow for vendors to add some custom features to extend the functionalities of this editor according to their needs. We believe that, and actually it's not only our belief, but it's confirmed by many parties, that such a tool would solve many issues of the current UI development workflows in the embedded world. So we are working on such a tool right now. I think some early screenshots or videos can be available in like 6 months, and we are targeting 12 months of development period with the first public and the production-ready version. So I hope on the next RT-Thread conference, I can talk you about this new UI editor toolkit and how it works together with RT-Thread as well. And that's it. Thank you very much for your attention. If you have any questions, I would be happy to answer them.
Well, thank you so much, Gabor. I remember your talks last year and the year before, and every year it seems there's something, ever more exciting with LVGL. I'd not heard of Lottie animations before, but I remember back in the early days, GIFs, animated GIFs, just seemed so wonderful at the time.
Yeah.
But that was in the days when videos or animations were only about the size of a large postage stamp.
Oh
So
yes. Yes, the Lotti animations are really interesting today. We had a meeting with an important party behind this whole Lotti movement, and they are working on making it a web standard actually. And if they will succeed in them, and I hope they will, it will be very popular all around the world,
yeah,
like a new image format that everyone knows.
excellent, excellent. One question Marcy asked: is there an overview which GPUs are supported?
Yes, you can find it in LVGL's documentation page, but I can briefly summarize it. So obviously we support Renaissance Div2D, as I already mentioned in the presentation. We have support for NXP's PXP, which is a simpler GPU, but we already also support VG Lite. VG Lite is a vector graphics GPU that can be used to do really amazing things. Actually, we have a platform-independent VG Lite implementation as well, which is not bound to NXP, but can be used by any VG Lite GPU. So yeah, a little bit of context. VG Lite is created by VeriSilicon, and it's used in many or several microcontrollers. Many vendors are using the VeriSilicon VG Lite GPU, and if a vendor uses it, it's supported in LVGL. We have also received the first pull request from ThinkSilicon. They are doing the NEMA GPUs, which are in the STM microcontrollers. So we are reviewing the pull requests, and they will be merged very soon. So the STM related or kind of GPUs will be supported in LVGL as well very soon.
Awesome. I was interested when you said that helium is giving better acceleration than a lot of GPUs. I hadn't even thought about helium in the context of user interfaces.
Oh, sorry, repeat the question.
I hadn't thought about helium in the context of user
Ah,
interfaces, so I was interested to hear that the
ah,
helium was giving better performance than GPUs.
Oh, yeah, it's a big surprise for us as well, to be honest. It's quite counterintuitive that the GPU is not faster than the software rendering. It's just offloads the CPU. But Helium is like magic. It's
Yeah.
really the same CPU usage as the GPU, but it's pure software.
Right. Very interesting indeed. The only other thing that strikes me, LVGL is brilliant for creating fantastic user interfaces. The only downside is that creating a user interface takes a certain skill. So it's not just the graphics, it's the hierarchy of the what does what where. How do people learn that? Where do people go to learn user interface design?
You mean the artistic part, creating something good looking?
No, not the artistic part, the underlying, think of a menu structure
Uh-huh.
or the hierarchy of how everything works. I have a Subaru and I'm supposed to be an expert in computing and I can't program the clock.
Oh, okay, I see. Yeah, to be completely honest, LVGL is not the simplest thing that you can use. There are some really drag and drop stuff that anyone without any skills, like low code or no code tools, So even my mother can put together a UI with them and flash them to the board and be happy with, you know, having some buttons and labels. But it's not professional. Usually these has their own limitations, and life is all about trade-offs.
Mm-hmm.
Something cannot be super simple and intuitive even to my mother, and yet fully flexible. And
no, I'm not saying that at all. What I'm saying is that with LVGL, people can create fantastic user interfaces, but a lot of people who create the user interfaces aren't expert at thinking how users will use them. So they don't put, you know, you would have a button that says set time, but they put it 3 menus down. Or, you know, where do people go to actually learn the theory of user interface design?
Okay, gotcha. Yeah, it's like now we are talking about basically three topics: the developer who implements the UI designer who creates the artistic part, and the UX, the user experience expert, who figures out in what menu shall you put the items. And it's a completely different job for a different mindset, for a different team of people. Actually, they are doing a lot of user interviews, trying to out what is the best workflow for the users. So I think in general, it's not something where LVGL can help. There are something where we can help the users, to be honest. The editor that I have mentioned we are working on will focus on components. So we can build up a larger and open component library where people can put together like simpler or more complicated components. This can be just a nice slider or a nice slider box with plus minus buttons, title, and something more complicated. Or it can be a whole UI as well, where you have a settings menu where things are arranged very nicely. And of course, we can also add, we as LVGL, we can also add components like reference designs to this component library, which can be a good starting point for users who doesn't have a team behind with UI and UX experts.
It's the UX thing. I think anything you could do to guide people, you know, even if it's just telling them go and read this book, you know, or something like that. We have another question here. We've got time for one more question. Are there any minimum requirements if we want to add support to any other existing 2D accelerator chips or embedded GPUs? Taking into account that LVGL v9 supports assembly?
Actually, there is no minimum requirement. You can take a look at how the current GPUs are implemented, and you can do the same with any GPUs that you like. Very briefly, it works like LVGL creates so-called draw tasks, and these draw tasks like draw a rectangle with this radius, or draw a border with this border width and this radius and color and opacity. So these are the draw tasks. These are in a list, and the task of a GPU is to consume the elements from this list of draw tasks and draw them one by one.
Okay, awesome. Well, thank you so much. Like I say, every year it gets